have a color pen that's different than any other color pen you've used all chapter. That's just my advice. If worse comes to worse, okay, fine, just a highlighter, just a colored pen. I'm going to be talking about things in your notes. I'm going to be referring back to concepts or forever cards. And it might be good to write down some of these things. But since I'm about to lose some of your attention, because some of you might just work on the practice test for the entire rest of class, if the test review went quite well. Do you want some specific hints about the test right now? Let's do this before I start losing people's attention. So whether you want to go to your notes at the very end, whether you want to go on your test review itself and just kind of write down the main topics, I can give you some hints for the test tomorrow. You ready? Let's do some particulars. First particular, no calculator may be out or used the entire test. So that means there will be no tables.
Yay.
Yeah, right? Who likes tables? So no calculator for the entire test, you know now. If you care, multiple choice will be worth about 4 points each. Long answer about double that, about 8 points each. I said usually it's 10 to 15 multiple choice, but this time, since some limits go really fast, I was able to fit in 17, which is awesome, because that means they're worth fewer points. Normally multiple choice are worth more, like 6 points each. But there are 4 long answers. There are 4 long answers, some of them with multiple parts. You have limits going to constants that work or that don't work. The ways those limits might not work: 0 over 0 or number over 0. Or a piecewise that doesn't match up. You're going to have piecewises that are less than or equal to greater than, but also piecewises that are not equal to and equal to. I need to know how to deal with both. You're going to have some questions that make you remember some properties. Like in the flip book, the ones with F's and G's, or in our notes, the ones with L's and K's. Or like some of the special limits with trig specifically. Trig is going to show up multiple times on the test, and sometimes you will need to be able to do the unit circle, and possibly not just for the basic SOHCAHTOA, but maybe also the CHOCHA. Maybe also secant, cosecant, and cotangent. Be ready. You're going to have some questions about continuity. How to make piecewises continuous. Ooh, that was like homework. How to find where functions are discontinuous. How to use the definition of continuous to show or to explain why something is or isn't. Now guys, if you're using the definition of continuous, how many talking points are you going to have? 3. And even if it fails at the very beginning or if it fails at the very end, just show me what the 3 are for the definition of continuous and say whether or not it's true by talking about the specific example. Does f of c exist? Yeah, here's the point. It's right there. Okay, cool. Does the limit exist? Yeah, because it equals this number. Or no, it doesn't exist because whatever. And does the point equal the limit? Yes or no? You're showing me that. You're going to be identifying discontinuities as removable or non-removable based on the function. And then you're going to be going to, did I mention vertical asymptotes? I didn't, sorry. I mean, I said removable, non-removable. You're going to be talking about vertical asymptotes, whether you're finding them or whether you're taking limits towards them. That would be number over 0. That would be like section 1.5. And then there's going to be section 1.6, how you're going to infinity, or you're going to negative infinity, or you're looking for horizontal asymptotes or totes. Totes or totes. Anyway, find the horizontal asymptotes, and there might be more than one. Otherwise, any other hints I'm going to give you will probably come from me going over questions in the review. So, if there's time at the end, questions in the practice test as well, if you've already started it. So, people who are going to be working on the practice test and mostly ignoring me, can you just keep an ear open for if I say something like, hey, everyone might want to pay attention, this is a great question, because I'm giving you a hint on the test, yeah? Here we go. Chapter 1 test review. I have the book open and I have the answer key open. Is there anything that you guys would like to see? Yeah, what?
20.
Number 20. I'm just going to write the questions up here on the board. What else?
59.
59. What else?
58.
58. What else?
86.
60. 69. And John?
86.
57.
57. And then Adam, you said 20?
23.
Okay.
42.
72? 74. Anything else? Okay, I think it's more than enough to get started, right? Some days, if we have tons and tons and tons of questions, I might just get people up to the boards and then they just work all around the room and you guys can take pictures on the way out. But just because it's our first test, if you guys don't mind, I would love to answer as many as I can for you. Is that cool? But once again, if you don't have a certain question, just play with your practice test. Yeah? But if you do have a certain question, then just be listening up. And yes, all this will be recorded. I will probably record periods 1 and 6 because your guys' questions might be different. Not that you have to go watch them, but you can. All right, I saw like a little clumping around 20 and 23 and another clumping around the 50s. So let's go find 20 and 23. They were both just finding the limit. So let me get both of them real quick in the picture. Number 20 is a conjugate, and 23 is a trig. Number 20 is a conjugate, and number 23 is a trig. So let me get over here because then it's a little bit easier. Okay, starting with number 20. Number 20, what happens when you guys plug in? For those of you that are paying attention. Yeah, you get 0 over 0, right? Now you have to be pretty careful. Some of you might not have thought of square root of 4 as 2. But for number 20, you do get a 0 over 0. Remember tomorrow, especially if it's a long answer problem. Long answer problems. Why didn't I tell you which were multiple choice or which were long answer? Oh. Definition of continuous, that's a great long answer. Removable, non-removable, that's a great long answer. Doing like a nasty limit that takes multiple steps, that's a great long answer. Finding limits given a graph, like multiple limits with one graph, that's a good long answer. Not that you have to explain, but just multiple parts to one problem. Ooh, finding a horizontal asymptote of kind of a nasty function, that's a good long answer. I think I got them all. All right, so since we have 0 over 0, you guys can look at your flip book also. Hopefully you know that you would have to do the conjugate. The conjugate, you only flip the sign as like a big old binomial of the middle sign. So keep the 4 plus x under. If you look in your flip book, we never distribute the bottom because it's not going to be helpful. We only distribute the top. Because on the bottom, we really want this x to be reduced away. He's the 0, he's the problem. So we leave this guy just as is, but on top we FOIL. When we FOIL, that square root squared, the square root just disappears. Our outer inner cancel. It's a difference of squares. Every conjugate always is. A minus b times a plus b is a squared minus b squared. If everything works out well, hopefully those constants will reduce. They should. The x over x, the 4's will cancel, the x's will reduce. The 4's will cancel, the x's will reduce. Careful on the long answers tomorrow. You have to keep rewriting the limits. Find your tendency tonight. If you tend to drop the limits, I had someone in here the other day who usually does extremely well in calculus. They stopped writing the limits and they got stuck because they're like, well, now what? I'm like, write the limit. Oh. If you write the limit, what should you know to do to finish? Plug in. Dun, 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 dun. Good. Number 23 is a trig one, though. Actually, this is also, I think it's the exact same problem as the flip book. The flip book has this one. You have 2 options. One option is to multiply by the conjugate, 1 plus cosine of x. for the purpose of getting 1 minus cosine squared, which can become sine squared based on the Pythagorean identities, which may be something you cancel. Or we could multiply top and bottom by 1 over x, because limit as x goes to 0 of either of these guys would be a special trig limit. But I don't know which one makes more sense in your mind. Play with it and make it look different, or go towards the special limits. Which one? Play or special limits? Okay, so special limit, that's what we did in class. Special limits would say, I really want a 1 over x for each of these guys, because that's what the special limits have. And then according to our basic rules, we can actually take the limits piece by piece. You can look at your basic rules in your flip book, but we're allowed to take the limit of the top and the limit of the bottom. And we have literally, just by multiplying by 1 over x, made this guy into the special limit of 0, and this guy's special limit of 1, and 0 over 1 exists. Is that okay? Once again, if you want to see the other way, come on in and I'll show you the other way, how to play with it using your trig properties. Moving on, we had number 42. He's kind of off on his own. He's up here in the section that says find the limit if it exists. If it does not, explain why. And he's an absolute value, which is perfect. Even the BC kids hate the absolute value ones and the piecewise ones. Ask them how their chapter 2, which is really your chapter 1 test went. They also don't get as much partial credit. And they just have multiple choice because it's high stakes multiple choice. They have to get them right.
Oh.
You guys, I'm pretty nice. I give partial credit and I put in some long answers, so I'm giving you more points. But do you guys see this is 3 from below?
Yeah.
Okay. There's a very mathematical way of doing this, and there's a very experimental way of doing this. The very mathematical way, and we're going different ways because isn't there a problem of 0 over 0? Keep going. But the absolute value says, cross out, and you have, yay, I'm done. Okay, the mathematical way would say, let's think about this dude. Every absolute value is a piecewise function, where sometimes the inside stays the same, and sometimes the inside flips. For positive numbers, anything greater than or equal to 3, for positive numbers, well, we're lumping 0 in that, it stays the same. For negative numbers, what does an absolute value do? Flip it. So if x was anything less than 3, 2.9 or 2 or 1 or negative 10, the absolute value would flip. All we have to ask ourselves is, if we're coming from the left or from below 3, what scenario of this absolute value should I be thinking? Are they staying the same or are they flipping? They're flipping. 2.9. That would be a negative. The absolute value would flip it. So I can technically rewrite this, because I'm coming towards 3 from below, as steal who he actually is from below. And the nice thing is, as soon as I get rid of my absolute values by choosing the appropriate piece, now I can reduce and say, ha, that's just negative 1. Dun, 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 dun. The other way of doing it, which I don't suggest, which you could have done, is you could have made a table. It's okay, you can hate me, that's fine. It's experimental, all tables are. If we don't have our calculators, pause. Could you have plugged in 3.1 and subtracted 3? Yes. We have plugged in 3.1, subtracted 3. Wait, we're not supposed to be coming from above. Where are we supposed to be coming from? So you could plug in 2.9, you could plug in 2.99, you could plug in, now you might be like, this is awful, I can't do this math, but guys, you're subtracting. 2.9 minus 3 would be negative 0.1, absolute value all over negative 0.1. Don't these just reduce? But what's your sign? Isn't it a positive over a negative? That's a negative 1. Okay, this one would be negative 0.01. All over negative 0.01. Oh, they reduced, but I still have a negative. You see it? Now I can keep going. This would be negative 0.001 over negative 0.001. They reduced, but they were negative. From below, all the values are going to be negative 1 because they're going to be the exact same. They always reduce, but a negative is left. From above, you would be choosing the other piece. It would be a positive 1. And so what would be the limit if they had just asked for x approaching 3? No above and no below. Does not exist because they would not agree. But from below, it's -1. From above, it's +1. Okay, good question, great question. Piecewise functions, or I should say absolute values, do freak people out. But if you rewrite them and then take the appropriate piece, it actually gets a lot simpler. Now in that weird 57 to 59 section that you guys were hating, what was going on there? Oh, continuous. Oh, and 59 was IVT. Okay, let's do 57, 58 first. Guys, didn't I say that continuous is a thing on the test? Continuities, discontinuities, and discussing whether or not it's continuous based on the definition of continuous. So I'm going to do these ones like a long answer on the test. Sound good? I'm going to do these ones like a long answer on the test, using the definition of continuous to explain whether or not, oh look, and it's a not equal to, equal to, and a less than or equal to, greater than. I think I said that too. Nice. Whoever's asking questions, good job. So how do we test for continuity of this one? Kiddos, does f of 1 exist? Remember, definition of continuous, f of c must be defined. Is he defined? Yeah. What's he equal?
Yeah.
Check. 1's good. You see me using the definition of continuous?
Yeah.
Why am I looking at 1? Because he's the only separator and he's the only possible problem. So everything else is fine. I don't care. Only 1 is the worrisome one. So then I'm checking at 1. What's the second part of the definition of continuous? Good. The limit, careful, you have to write it right tomorrow. The limit as I'm approaching 1 of f of x. Who am I looking at if I'm approaching 1 with a not equal to piecewise? Why that's hot? I totally agree. But why do people get confused by that?
Because they're going to get confused by the not equal to 1. I think.
Because they're going to think that they need to, no, but he's the point. He's okay. He's the at. If you need to, just remind yourself. He's the at. He's the approach. Now, down here, why am I going to say this one is the at and the approach?
It's equal to.
And this one is the approach?
It's greater than equal to.
Because this one has the at and the approach. One of the approaches, right? And this one has the other approach. So piecewises behave very differently. But both approaches are right there. If I plug in 1, I think I get 0 over 0, right? That doesn't mean we're done. That just means we keep going. So maybe we should factor the top. The Calculus Chapter 1 test is not the time to teach factoring, but if you need to review factoring, come in, whiteboard, we'll do it. But we're going to get 3x, and we're going to get x, and we're going to get 1, and we're going to, no, and we're going to get 2, and we're going to get 1, with a negative and with a positive. Nice thing is, we knew he was reducible, removable. He's a whole. So what's left? I kept rewriting my limit, so I know what to do. Would you? Plug it in, 5. Does the limit exist? Yes. What's wrong?
It's the approach and the at.
Is it okay if we just cheat and be lazy and say that's not true?
Yes.
So therefore the at doesn't equal the approach. Therefore, I can say my function is discontinuous at x equals 1. Is that good? What's different up here is I would have said, what is f of 2? He is fine. Domain, all real numbers, no discontinuities. They're both polynomials. They're fine, but the separator I have to check. So one place it can break. But f of 2 does exist. The or equal to says plug it in, yay. Find the limit. Why am I going to have to do a timeout real quick? Oh, that was not. Sorry. That x is approaching what? 2. Good. To find this and then have to do from below and from
above.
That makes sense, right? The piecewise. There is a below. It's 5 minus x. And there is an above. It's 2x minus 3. Plug it in. That's 3. Plug it in. That's 1. So what does that mean? D and the limit does not exist. Right? So where does it break down? I probably probably shouldn't box it. That was kind of awkward. But, long story. Oh, I can't undo. Oh, and I put a 3 instead of a 2. Struggle, guys. I apologize. That was condition 2 of the definition of continuous, not condition 3. And so we could say technically, if you were trying to show me that you know the definition of continuous, you want as many points as possible in case you made a mistake, then you could go ahead and say, well, if that's true, then guess what's not going to work either? Yeah, but that doesn't work because he's DNE. So if you want, you could be super snazzy and say, well, I know what I would have gone looking for, but that proves my function is discontinuous at x equals 2. For both of these, they are non-removable discontinuities. Oh no, he's non-removable because my graph is broken. The limit does not exist. He's removable because the limit exists. The point's just in the wrong spot. If you guys want to think about it, this one is removable, and this one is non-removable. But if I'm asking you removable and non-removable on the test, it's probably just like a rational function, not a piecewise, where you just have to factor and see which ones go away and which ones don't. Then I see some questions around 69, 74, 86. Let me go peek and see which ones are most useful for tomorrow. Sound good? Number 69 is hiding. Oh, here he is. 69 is the one-sided limit. 74 is another one-sided limit. And then 86 is going to infinity. Let me grab pictures of all these just for me to do some hints. So we have 74, 69. And then we have, I would say factor on 69. 74, it's a number over 0. We need to check the sign of the infinity. And then in number 86, he's a degree test, unless you want to do it the super snazzy way. Okay, number 69, my advice would definitely be to factor, because otherwise it's really hard to plug in 0.9 from below, if it's like that. So I would definitely factor this guy to have been x plus 1 squared, right? If we plug in, do you guys see how this is going to be 2 over 0? This is number over 0. To help you guys out, remember how I said I was going to take period 1 and 6? I'm going to start period 6 questions from the end of the review. Sound good? Because I bet I'm going to hit on these ones, number over zeros, and work backwards. So you guys can go check out their video just at the very beginning. And then you'll get the questions that you need. Or pop by. Not during lunch. Sorry, staff appreciation on teaching. Never. 7th period are after school. I'll be here till 3:25. Alright guys, have an EB kid on backup call or text tonight. Have a BC kid on backup call. Text tonight. You guys got this.